So today we're talking about solving simultaneous linear equations, and sometimes an unknown has to satisfy two or more linear inequalities simultaneously. When we're in that situation, we use the word "and" to connect those two inequalities. You'll notice over here. Then the solution of x is the common solution to all of those simultaneous linear inequalities. So let's take a look at this first example. Solve the inequalities 2x plus 3 is less than 9 and 3x minus 7 is less than 8. So the first thing we're going to do is go ahead and solve 2x plus 3 is less than 9. So we have 2x plus 3 is less than 9. And then first thing I'm going to do is subtract 3 from both sides. So I have 2x is less than 6. So that tells me that x, not equals. We're dealing with inequalities. X is less than 3. Now I'm going to go ahead and solve the other inequality. 3x minus 7 is less than 8. Again, another not so great 8. But anyway, here we go. So 3x is less than 15, and x is less than 5. So I have x is less than 3, and x is less than 5. So what I'm going to do is take all that information, place it on a number line. Let's see, let's go ahead and make, here's 0, here's 3, here's 5. Alright, so my first solution, x is less than 3. I'm going to take my empty dot. Show because 3 is not part of my solution. Goes this way. Then I have my empty dot at 5 because 5 is not part of the solution to represent x is less than 5. Now what we'll see is that x satisfies x is less than 3 and x is less than 5. We find the common part of both solutions. And the common part of both solutions comes in this part over here where x is less than 3. And that means in terms of having a common solution, they're both the same answer after this spot. So then my answer is going to be x is less than 3. So in this case I had an example where one of the inequalities was a solution to both inequalities. Let's take a look at a different example. Solve the inequalities 5x plus 13 is greater or equal to 2x plus 5, and, again, so I'm combining two situations, 3x minus 7 is greater than 9x plus 11. So first thing I'm going to do is solve my first inequality. 5x plus 13 is greater than or equal to 2x minus 5. I'm going to go ahead and subtract 13. So I get 5x is greater than or equal to 2x minus 18. And then I'm going to subtract 2x from the right-hand side. So I get 3x is greater than or equal to negative 18. And x is greater than or equal to negative 6. Now I'm going to solve the other inequality. 3x minus 7 is greater than 9x plus 11. Let's see, first thing I'm going to do is add 7 to both sides. So now I have 3x is greater than 9x plus 18. Maybe I should have done something else. Oh well, here we go. So I'm going to subtract 9x. And now I have negative 6x is greater than 18. Which means, after dividing both sides by negative 6, x is less than negative 3. Don't forget, you remember when you're multiplying or dividing by a negative, you have to flip the sign. So now if we take a look, let's make a number line. Oh, that's not a very pretty line, is it? There we go. Big erasers for big mistakes. And number line. All right, there we go. So we'll see, let's take my value here of negative 6, negative 3, and then 0. There's my number line. So my first solution, x is greater than negative 6. I have the solid dot because negative 6 is part of my solution. X's value is greater than that. And then I have my second solution, x is less than negative 3. So an open dot at negative 3, continuing on this way. And then what we see is that my solution is in between these values over here. So anyway, as I was saying, we have our solution. And then that means here in this case, if we're taking a look, then the solution is in between negative 6 and negative 3. So what I'm going to say in my solution is that x is greater than or equal to negative 6 because it is, but it is also less than negative 3. So definitely drawing things out on a number line helps you to figure out a solution. Let's take a look at one last example because it's going to be a little different than the last. Solve the inequality x plus 1 over 3 is less than x minus 2 over 4 is less than x. So the first thing we're going to do is set up two separate inequalities. So x plus 1 over 3 is less than x minus 2 over 4, and x minus 2 over 4 is less than x. So first thing I'm going to do, and you can treat this less than symbol the same as an equal symbol for the time being, which means you can go ahead and think about cross multiplying. So we're going to have 4 times, in parentheses, x plus 1 is equal to 3, in parentheses, x minus 2. Except since we're dealing with an inequality, it's not really equals, but we're going to go back and make that an inequality. So, but like I said, you kind of use the rules in the same way as we've established before. So 4x plus 4 is less than 3x minus 6. So 4x is less than 3x minus 10, which means x is less than negative 10. So that's the first half of the inequality. And then we take on the next half. I'm going to multiply both sides by 4. So I get x minus 2 is less than 4x. Since I multiplied both sides by 4, is the common denominator. And then x is less than 4x plus 2. Negative 3x is less than 2. And x, I'm dividing both sides by negative 3, so think about what's happening to the sign here. Dividing by a negative, so x is greater than negative 2/3. All right, so here's where we really need to think about our answer, because if we create a number line, what we'll see is that you have, let's see, here's negative 10, here's negative 2/3. Again, this is not to scale. So positive 0 would be this way. negative infinity would be this way. That kind of looks like 8, doesn't it? Let's erase that. All right, so anyway, as I was saying, negative infinity. There we go. But anyway, let me get back to my answers. My first answer, x is less than negative 10. So open circle. All my answer values are this way. X is greater than negative 2/3. So open circle this way. What we notice is that there's no real number x that's going to be less than negative 10 and greater than negative 2/3. So here we have no solution. No solution. All right, so here are a couple of examples. Again, we've seen an example where one of the answers is true for both inequalities. There was a union of the two answers, and we had an example where there was no solution. Again, the number line helps us to see those values. That's it for solving linear inequalities.